Hello and welcome to the video lesson for section 2.1. This section is about solving systems of linear equations. So that means we have 2 or 3 linear equations that we need to solve. Alright, so if it's a linear equation, that means you can draw it on a graph as a line. And the graphing method really, it's not the most efficient and quickest way of solving these, but I'd like to show it just a little bit because it gives a nice visual representation of what's really going on. So I'll just do a few of these. So with number 1, so each of these are an equation of a line, and if I want to graph that line, I would like to get that equation in slope-intercept form, which you may recall is y equals mx plus b, where m is the slope and b is the y-intercept, and so we went over all that in chapter 1, so you should recall that. So we're just going to take each equation and put it in slope-intercept form. So for the first equation, we would just have to subtract 3x from both sides, and that would just give us y equals negative 3x plus 5. And then we're just going to do the same thing for the other equation. So in that case, we need to subtract 2x from both sides. So that would give us negative y equals negative 2x plus 5. And then we still have to get y by itself, so I would divide both sides by negative 1. So that would be y equals 2x minus 5. And then I'm just going to graph each of those. So the first one has a y-intercept at positive 5. So I plot that, and it has a slope of negative 3, so I just go down 1, 2, 3, and over 1. Let's see, let me go 1, 2, 3 over 1 again. Okay. Alright, and then the other equation has a y-intercept at negative 5. And the slope is positive 2, so I'm going to go up 2 over 1. And so that point of intersection, that is going to be the solution to the system. So that point right there, and the coordinates of that point is 2, negative 1. So 2, negative 1 is the solution to that system. And then number 2, the first equation is already in slope-intercept form, so I don't need to do anything to that one. And then the second equation, I need to get y by itself, so I'm going to add x to both sides. So that would give me 3y equals x plus 9. And then I just need to divide everything by 3. So that would make it y equals 1/3 x plus 3. Okay, so the first equation has a y-intercept at negative 2, and it has a slope of 1/3, so I'm going to go up 1 and over 3. And then the next equation has a y-intercept at 3, and it also has a slope of 1/3. So it goes up 1 over 3. And I'll also go down 1 and backwards 3 just for fun. Okay, so since these two lines have the same slope, they are obviously parallel, and they're never going to intersect, which means that this system has no solution. Okay, so no solution. Okay, and then number 3, so we have to get y by itself. So on the first equation, let me go ahead and just rewrite it so that it has y on the left side already. So it's 2y plus 1 equals x minus 3. And then we're going to subtract 1 from both sides. So that makes it 2y equals x minus 4. And then we're going to divide everything by 2. So that makes it y equals 1/2 x minus 2. And then on number 3, I would add x over 2 to both sides. So y equals x over 2 plus 2. And x over 2 is really the same thing as 1/2 x. Whoops, that's supposed to be minus 2. So, in fact, these two equations are actually the exact same equation. Okay, so I'll go ahead and graph that one line. Y-intercept is -2, slope is 1/2, so up 1 over 2. Alright, so since these equations are the same, we basically just have really only one equation with two variables. And so every point on that line, which is an infinite number of points, is a solution to that equation. So there's an infinite number of solutions. Okay, so now that we have a visual idea of what it is we're doing, let's look at some of the more efficient methods of solving systems. So the first one we'll look at real quick is the substitution method. So in order to do that, I have to have one of my equations where one of the variables is already isolated. So in this case, on the second equation, x is already isolated. So now that I know that x is equal to y plus 4, I can just take y plus 4 and I can plug it in place of x in the other equation. So when I do that, that's going to give me y plus 4 minus 2y equals 7. So now I can solve this equation for y. So y minus 2y would be negative y. So then I would have 4 minus y equals 7. And I'm trying to solve for y, so then I would subtract 4 from both sides. And then I would have negative y equals 3. So negative y is the same thing as like negative 1y. So then I would just divide both sides by negative 1. So y would be equal to negative 3. Alright, so now that I know what y is, I can go ahead and find out what x is by taking the negative 3 and plugging it in place of the y right there. So that's going to be x equals negative 3 plus 4. So negative 3 plus 4 would be positive 1. So x equals 1. And I always have to write my solution as an ordered pair with x comma y. So that's going to be 1 comma negative 3. Okay, and then let's do the same thing on number 5. So if I want to use the substitution method, like I said before, I have to have one of my equations with one of my variables already isolated. So the easiest way to accomplish that for number 5, since I don't have it already, would be to take the second equation and get x by itself. So to do that, all I need to do is just add 3y to both sides of that equation. So that would give me x equals 3y minus 3. And then now that I know x is equal to 3y minus 3, I can take that 3y minus 3 and I can plug it in place of the x in the other equation. And when I do that, that's going to be 2 times 3y minus 3 minus 5y equals negative 1. So now I'm just going to solve for y. So I'm going to distribute the 2, so that's going to be 6y minus 6 minus 5y equals negative 1. Combine like terms, 6y minus 5y would be y. So that would be y minus 6 equals negative 1. Then I'm just going to add 6 to both sides. So that gives me y equals 5. And now that I know that y is equal to 5, I can just take that 5 and I can plug it in place of the y right there. So when I do that, it's going to be x equals 3 times 5 minus 3. So 3 times 5 is 15. 15 minus 3 is 12. So x is equal to 12. And then let's write the solution as an ordered pair. So that's 12 comma 5. Okay. So now let's look at the addition/elimination method. So the reason why this is sometimes called the addition method is because it involves adding the two equations together, and the reason why it's sometimes called the elimination method is because it involves eliminating one of the variables. So on number 6, we can see that if we just directly add these two equations together, the y term will automatically cancel out because we have positive 2y and negative 2y. So let's add these two equations together. So x plus x would be 2x, and then 2y minus 2y would cancel out, and then 7 minus 5 would be 2. So now I just have an equation that says 2x equals 2, and then I can just divide both sides by 2, which would give me x is equal to 1. And then now that I know that x is equal to 1, I can just go ahead and take that 1 and plug it in, and I can use either one of these original equations. I'm going to use the first one. So that's going to be 1 plus 2y equals 7. And then I'm going to solve for y, so I'm going to subtract 1 from both sides. So that's going to be 2y equals 6. And then just divide both sides by 2. So that gives me y is equal to 3. So now I can just write my solution as an ordered pair, which is going to be 1 comma 3. Okay, so on number 7, now if we look at this problem, if we just directly add these two equations together like we did on the last problem, none of our variables are going to get eliminated. So before we actually add them, we need to multiply one of our equations by something so that when we then add them together, one of the variables will cancel out. Okay, so whenever you have a variable that has a coefficient of, say, 1 or -1, like for example in this case that would be this -y right here, so it doesn't really have a number in front of it. So that makes it kind of easy to say, okay, well, what number is in front of the y in the other equation? Well, it's +3. Okay, well, what would I have to multiply here with the first equation to make that a -3y, so it would cancel out with the +3y? Well, if I just multiply the first equation by +3, I'll end up with a -3y to cancel out with this +3y. Okay, so that's what I'm going to do. I'm going to multiply the first equation by 3. Now, you do have another option, which is you could have multiplied the second equation by -2, so that way you would get a -8x to cancel out with the +8x. So that's just another option that would have been probably just as good if you wanted to do it that way. But I'm going to go ahead and multiply by 3. So I have to multiply the 3 times the whole equation. So that would give me 24x minus 3y equals 51. And then I'm just going to bring the second equation over and rewrite it so that everything's all nice and lined up. That's 4x plus 3y equals 33. And then I'm going to now add the equations together. So 24x plus 4x would give me 28x. And then -3y plus 3y cancels out. And then 51 plus 33 would give me 84. So I have 28x equals 84. And then I'm going to divide both sides by 28. And that's going to give me x is equal to 3. So now that I know that x is equal to 3, I can take the 3 and I can plug it in place of x in either one of my original equations. I'm going to go ahead and use the second equation. So that's going to be 4 times 3 plus 3y equals 33. And now I'm going to solve for y. So that's 12 plus 3y equals 33. And then subtract 12 from both sides. So that gives me 3y equals 21. And then if I divide both sides by 3, that would give me y equals 7. Okay, and then I'm just going to write my solution as an ordered pair, x comma y. So that's going to be 3 comma 7. Okay, now if we take a look at number 8, so in this case, I'm going to have to multiply both equations by something. Okay, so first I just need to decide, do I want to eliminate the x's or the y's? And really, it doesn't make any difference. So I think I'm going to go with, let's eliminate the x's. So if I want to eliminate the x's, I would need to multiply the first equation by 3 and the second equation by 7. Only let's make one of them negative. It doesn't matter which one. But basically what I want to end up with is a positive 21x and on one of them and a negative 21x on the other one, so that way they would cancel out. So I'm going to multiply the first equation by -3 and I'm going to multiply the second equation by positive 7. So my first equation becomes negative 21x minus 15y equals 75. And on the second equation, I'm multiplying by 7, so that gives me positive 21x plus 49y equals negative 7. So then I'll go ahead and add these two equations together. And so negative 21x cancels with positive 21x. And then I'm looking at 49 minus 15. So that's going to be 34y is equal to 68. And then I just divide both sides by 34, which gives me y equals 2. Now that I know y equals 2, I can just take the 2, I can plug it in place of the y in either of these equations. I'm going to use the second one. So that makes it 3x plus 7 times 2 equals negative 1. So that would be 3x plus 14 equals negative 1. Subtract 14 from both sides. So 3x equals negative 15. Divide both sides by 3 and get x is equal to 5. Negative 5. So then I'm just going to write my solution as an ordered pair, x comma y. So that's going to be negative 5 comma 2. Okay, so on number 9, I'm going to multiply the first equation by 2. So that's going to give me 10x minus 14y equals 24. I'm just going to bring the second equation over so we have everything lined up. So that's negative 10x plus 14y equals negative 24. So at this point, a lot of people tend to kind of flip out, but there's no need for that. Just go ahead and continue to add these equations together just like you always would. Okay, so since 10x cancels out and 14y cancels out, but we need to write something, so that's going to be 0 equals 0. Okay, so that is a true statement. 0 is equal to 0. But that's not a very helpful statement as far as figuring out what are the x and the y. So what that actually means is that these two equations are actually the same. And so this is one of those situations where we would have infinite solutions. Okay, now when you're doing your homework on the computer, they're going to want you to write down a general solution. Okay, so to do that, we're going to take one of our equations and we're just going to get one of our variables by itself. Okay, so I'm going to get x by itself by adding 7y to both sides. So that gives me 5x equals 7y plus 12. And then just divide both sides by 5. So that gives me x equals 7y plus 12 all over 5. So I can then write my solution So x is 7y plus 12 all over 5. And then y is just y. And that would be how the solution would be written. Alright, and then number 10. So for this problem, I would go ahead and multiply the first equation by 3. And then that would give me 9x minus 33y equals 27. And then I'm going to bring the second equation over, so that's negative 9x plus 33y equals 18. Okay, so if you add these two equations together, all of this cancels out, so this side of the equation is 0, but 27 plus 18 is going to be 45. So 0 is not equal to 45, so that's a false statement. So because of that, this is actually going to be no solution. Okay, so now let's start getting into some applications. So here's a simple word problem to start off with. The difference between two numbers is 10. If 3 times the larger is added to twice the smaller, the result is 70. Find the two numbers. Okay. So the difference of two numbers is 10. So based on that statement, I could write down that x minus y equals 10. Okay, now by writing that statement in that way, I've already decided that apparently x is the larger number and y is the smaller number. Okay, so then it says if 3 times the larger, so that being 3x, is added to, so that would be plus, twice the smaller, so that would be 2y, the result is 70, so that would be equals 70. So now all I have to do is just solve this little system. So I would just go ahead and multiply the first equation by 2, which would give me 2x minus 2y equals 20, and then bring the second equation over, which is 3x plus 2y equals 70, and then add these two equations together. So 2x plus 3x is 5x, negative 2y cancels out with positive 2y, and 20 plus 70 is 90. So then just divide both sides by 5. So x is equal to 18. And now that I know x is equal to 18, I'm just going to plug that back into my first equation, which said 18 minus y equals 10. And so subtract 18 from both sides. Negative y equals negative 8. Divide both sides by negative 1, so y is equal to 8. So the two numbers are 18 and 8. Alright, number 12 says a Broadway performance of Les Mis had a paid attendance of 308 people. Balcony tickets cost $38 and orchestra tickets cost $60. Ticket sales receipts totaled $15,576. how many tickets of each type were sold. Okay, so we need to define the variables. So X is equal to the number of balcony tickets sold. Okay, so it's important to be very specific when you're defining your variables. Alright, so, it's better to say X is equal to the number of balcony tickets sold rather than just saying X equals balcony. Okay, and then Y is equal to the number of orchestra tickets sold. Okay, so it says that they had a paid attendance of 308 people. So that means X plus Y equals 308. Okay, balcony tickets cost $38, orchestra tickets cost $60, and the ticket sales receipts totaled $15,576. Okay, so that tells me that 38X plus 60Y equals 15,576. So to solve this, I would multiply the first equation by negative 38. So that would give me negative 38X minus 38Y equals 38 times 308 is 11,704. So that's negative 11,704. And then I'm going to bring the second equation over, which was 38X plus 60Y equals 15,576. Then I'm going to add these equations together so the x's cancel out. 60 minus 38 would be 22y. Okay. What happened to my calculator? Where'd it go? Okay, calculator. So I'm doing 15,576 minus 11,704 equals 3,872. And then let's divide both sides by 22. And that gives me 176. So y equals 176. So I'll plug that back into the first equation. So x plus 176 equals 308. So let's subtract 176 from both sides. .308 minus 176 is 132. Okay, so let's write our answer as a complete sentence. So they sold 132 balcony tickets. And 176 orchestra tickets. Okay. So next, we're going to move on to solving systems of 3 equations with 3 variables. Okay, so to do this, we want to think about trying to reduce this down to a 2-variable system. And in order to do that, we need to eliminate one of the variables. And in order to get 2 equations that only have 2 variables in them, we need to eliminate that same variable 2 times. Okay, so just pick whichever variable we think would be the easiest to eliminate. In this case, I would pick y because I know on the first 2 equations, if I just add those together, the y already cancels out. And then later, I'm just going to multiply the second equation by 3 and add it to the third equation and eliminate the y for the second time. But first, I'm just going to add the first 2 equations together. So 2x plus x would be 3x. The y's would cancel out. 3z plus 2z would give me plus 5z. And 2 minus 4 would give me negative 2. Okay, and then, like I said, the next thing I'm going to do is multiply the second equation by 3. That way I'll get a negative 3y to cancel out with the positive 3y on the third equation. So when I multiply that by 3, it gives me 3x minus 3y plus 6z equals negative 12. Then I'm going to add that together with the third equation. So x plus 3x gives me 4x. The y's cancel out. And then negative z plus 6z gives me plus 5z. And 1 minus 12 is negative 11. Okay, so now I'm looking at the red equation and the green equation, and this is now my new smaller problem that I'm going to solve. And I see that both of them have a 5z, so that means if I just multiply one of them times negative 1, I'll get a negative 5z to cancel out with the positive 5z. So I'm going to multiply the first the red equation, which is now the first out of these 2 equations, multiply it by negative 1. Alright, so that gives me negative 3x minus 5z equals 2. And then I'm just going to bring this one over and line it up, so that's 4x plus 5z equals negative 11. So now I'm adding these 2 equations together. So negative 3x plus 4x would give me 1x, or in other words, just x. The z's cancel out. And then 2 minus 11 is negative 9. So now I know that x is equal to negative 9. And I'm just going to put a couple little hash mark underlining just to show, hey, this is one of my answers, but not my final answer yet. So now I would take that negative 9 and I would plug it in place of the x in one of my 2-variable equations. So that would be like right here. So that would be 4 times negative 9 plus 5z equals negative 11. So then that would be negative 36 plus 5z equals negative 11. And then I would add 36 to both sides. So that would make that 5z equals 25. And then I could just divide both sides by 5, which would give me z is equal to 5. Okay, so the last thing I have to do is just to find out what is y equal to. So to do that, I'm going to, I can use any of my original equations that has all three of the variables in it. I'm going to choose to use the first equation though, okay, which is 2x plus y plus 3z equals 2. And then I'm going to plug in the negative 9 for the x. So it's 2 times negative 9. I still don't know what y is, so I'm just going to write plus y plus 3. And then I'm going to plug in 5 in for the z, so it's plus 3 times 5. So I've got 2 times negative 9 plus y plus 3 times 5 equals 2. Okay, so that'll be negative 18 plus y plus 15 equals 2. And then combine the like terms, negative 18 plus 15 is negative 3. But I've still got, so it's y minus 3 equals 2. Then I'm just going to add 3 to both sides. So y is equal to 5. So now in this case I'm going to write my solution as an ordered triple, x comma y comma z. So that's going to be negative 9 comma 5 comma 5. Okay, so let's do another example, number 14. So again, I'm going to pick out one of my variables that I can eliminate 2 times, and it just so happens that in this case, the easiest one is also y. Okay, because I can add the second 2 equations together and get rid of the y, and then I can just multiply the second equation by 2 and add it to the first equation to get rid of the y for the second time. Okay, so let's add the second 2 equations together. So x plus 3x would be 4x. The y's cancel out. 3z minus 4z gives me negative z, and negative 5 plus 10 gives me positive 5. Okay, and then I'm going to take the second equation now, and I'm going to multiply it by 2, so that way I can add it with the first equation. I can get negative 2y to cancel out with that positive 2y. So this is going to give me 2x minus 2y plus 6z equals negative 10. And I'm just going to bring that first equation over, which was negative 4x plus 2y plus z equals 1. And then I'm going to add these 2 equations together. So negative 4x plus 2y would be negative 2x. The y's cancel out. And then z plus 6z gives me plus 7z. And then 1 minus 10 gives me negative 9. Okay, so now I'm looking at the red and the green, and I see I have a negative z on the red one, so I could just multiply that by 7 so that it would cancel out with the 7z in the other equation. Or if you wanted to, you could multiply the green one by 2 so that you would cancel out the x's. But I'm going to go with the 7. So I'm going to multiply this red equation by 7. So that's going to give me 28x minus 7z equals 35. So then I'm adding these 2 things together. So negative 2 plus 28 is going to give me 26x. Z's cancel. 35 minus 9 would be 26. So then just divide both sides by 26. And I've got x equals 1. Okay, so now I can take that and I can plug it in for x on one of my two variable equations, so that way I can find out what z is. So it's going to be 4 times 1 minus z equals 5. Okay, so that is 4 minus z equals 5. Subtract 4 from both sides, so negative z equals 1, and then divide both sides by negative 1, so z equals negative 1. Okay, so now I just have to find out what y is. So I'm going to go back and grab one of my original 3 variable equations, and you can use any of them, but I'm going to choose the third one. Okay, so that was 3x plus y minus 4z equals 10. And I'm going to plug in the 1 for the x. So that's 3 times 1 plus y minus 4 times negative 1 equals 10. Okay, so I have 3 times 1 plus y minus 4 times negative 1. Okay, so that's 3 plus y plus 4 equals 10. Combine the like terms. 3 plus 4 is 7. So I have y plus 7 equals 10. And then subtract 7 from both sides and get y equals 3. So then I'm going to write my solution as an ordered triple, x comma y comma z. So in this case that's 1 comma 3 comma negative 1. Okay, so here is going to be a word problem with 3 variables. So in January 2006, Kobe Bryant of the LA Lakers had the highest scoring game of his career. He made 46 shots for a total of 81 points. He made several free throws worth 1 point each, several regular shots worth 2 points each, and several 3-point shots. He made 3 times more regular shots than 3-point shots. How many of each type of shot did he make? Okay, so I'm going to have x equals number of free throws I'm going to have y equals number of 2-pointers and z equals number of 3-pointers. Okay, so it says that he made a total of 46 total shots. So that means x plus y plus z equals 46. Then it says he made a total of 81 points. So that would be 1x, or just x, plus 2y plus 3z equals 81. Okay, then the trickier one, he made 3 times more regular shots than 3-point shots. Okay, so they're saying that he made more of the 2-pointers, 3 times more of the 2-pointers than of 3-pointers. Okay, so for that, we could say the number of 2-pointers, which is y, is equal to 3 times the number of 3-pointers, which is z. Okay? So if he made 2 3-pointers, that means he made 6 regulars. Okay? Now, to put that equation into the same form as the rest of them, I would move the 3z over, and I would make it y minus 3z is equal to 0. Okay, now since my third equation already doesn't have an x, I think the best thing to do would just be to eliminate the x from the first two equations. And to do that, I would just multiply one of them by -1. So I'm going to multiply the first equation by -1, which gives me negative x minus y minus z equals -46. And then I'm going to bring the other one over, which was x plus 2y plus 3z equals 81. And then I'm going to add these equations. So the x's are going to cancel out. And then 2y minus y is y. 3z minus z is 2z. And then 81 minus 46 is 35. Okie dokie doke. Now let's see. So what I could do is I could multiply this equation by -1, and that way I can cancel out the y's. So that would give me negative y plus 3z equals 0. And then when I add these two equations together, the y's cancel. 2z plus 3z is 5z, and 35 plus 0 is 35. So 5z equals 35, so just divide both sides by 5, and that gives me z is equal to 7. So now I know he made 7 3-pointers. And then I could take that 7 and I could plug it in right here, and that would give me the number of regular 2-pointer shots that he got. So 3 times 7 is 21. Okay, and I know that the total number of shots was 46. X plus y plus z equals 46. So I'm going to plug in my y and my z so I can find out what x is. So x plus 21 plus 7 is equal to 46. So 21 plus 7 is 28. So I've got x plus 28 equals 46. Then I just need to subtract 28 from both sides. So that's 18. Okay, so now I'm going to write my answer as a sentence. Okay, so he made 18 free throws and 21 2-pointers and 7 3-pointers. Okay. Last problem. A restaurant owner orders a replacement set of knives, forks, and spoons. The box arrives containing 40 utensils and weighing 141.3 ounces, ignoring the weight of the box. A knife, a fork, and a spoon weigh 3.9 ounces, 3.6 ounces, and 3.0 ounces, respectively. How many solutions are there for the possible number of each type of utensil? Find the solution with the smallest number of spoons. Okay, so let's write down, first of all, define the variables. So x equals number of knives y equals number of forks, z equals number of spoons. Okay. So we know that there's a total of 40 utensils. So that tells me x plus y plus z equals 40. And then we know the weights and what the weight adds up to. So that's going to be 3.9x plus 3.6y plus 3z equals 141.3. Okie doke. So what we want to do, those are the only two equations that we have. So we know that we're not going to be able to find one unique solution probably. So let's see, they're basing everything on the number of spoons, which is z. So what I want to do is get x in terms of z and y in terms of z. So to do that, that means I'm going to need to eliminate the x once, and I'm going to need to eliminate the y once. Alright, so I guess let's just start off by eliminating the x. So to eliminate the x, I would multiply the first equation by negative 3.9. So that would give me negative 3.9x minus 3.9y minus 3.9z equals negative 3.9 40 times, no, I don't know how to do negatives on this silly little calculator, so I'm just going to do 40 times 3.9. That's 156, so I know it's negative 156. Okay, and then I'll bring this over. That's 3.9x plus 3.6y plus 3z equals 141.3. Okay, so when we add these together, this cancels out, and then we're going to have negative 0.3y minus 0.9z equals negative 14.7. Okay, so now we can get y in terms of z. So we're going to get y by itself right now. So I'm going to add 0.9z to both sides. So negative 0.3y equals 0.9z minus 14.7. Okay, then divide everything by negative 0.3. So y equals negative 3z, because 0.9 divided by 0.3 is 3, and then 14.7 divided by 0.3 would be 49. So y equals negative 3z plus 49. Okay, so now we basically have to do the same thing, and we have to get x in terms of z. So let's see, we could do it the same way, or we could just take what we know for y and just plug it in. So let's try that. So I'm going to take my first equation, and I'm going to take negative 3z plus 49, and I'm going to plug that in place of y in the first equation. So that's going to be x plus negative 3z plus 49 plus z equals 40. Okay, now I'm going to solve for x. So negative 3z plus z gives me negative 2z. So I have x minus 2z plus 49 equals 40. And I'm trying to get x by itself, so I'm going to add 2z to both sides. And I'm also going to subtract 49 from both sides. So that's going to give me x equals negative 9 plus 2z. So now I have x in terms of z. Okay, doke. So let's see. Well, since x represents the number of knives and y represents the number of forks, I know that those numbers, x and y, have to be greater than or equal to 0 because you can't have a negative number of knives or forks. Okay, so I'm going to say negative 9 plus 2z must be greater than or equal to 0. So add 9 to both sides. So 2z is greater than or equal to 9. Divide both sides by 2. So z is greater than or equal to 4.5. Okay, and let's do the same thing with y. So negative 3z plus 49 must be greater than or equal to 0. Okay, so let's subtract 49 from both sides. So negative 3z is greater than or equal to negative 49. Okay, and then I'm going to divide both sides by negative 3. So when I divide an inequality by a negative number, I have to flip the inequality. So I'm going to change it from greater than or equal to less than or equal to. So 49 divided by 3 is about 16.3. Okay, so now z represents the number of spoons. So that number obviously has to be a whole number. It has to be greater than or equal to 4.5 and less than or equal to 16.3. So that gives me, it can be 5, 6, 7, 8, etc., all the way up to 16. Okay, so if we count 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, that's 12 possibilities. So there are 12 possible solutions. Alright, now it said to find the solution with the smallest possible number of spoons. So the smallest possible number of spoons is 5. Okay, so if there are 5 spoons, we can plug that in for x. So x equals negative 9. So we're letting z equals 5 because that's the smallest value that it can be. Negative 9 plus 2 times 5, so that would give me x is equal to 1. And then y equals negative 3 times 5 plus 49. So that would be 49 minus 15 would be 34. Okay, so the solution with the smallest possible number of spoons would be 1 knife, 34 forks, and 5 spoons. Okay, so that is all. I hope that you found this video to be helpful. And please let me know if you have any comments or questions. I'm still a newbie at making these videos, so any feedback is great. And I'll try to get the next one out very soon. Okay, thanks for watching. Bye-bye.